Do you want to master simplifying algebraic expressions using the laws of indices? Here are 3 quick but powerful tutorials showing how to get it done by using indices, exponents, and surds. First up, let's simplify the expression on your screen. Ensure that the final fractional form does not have any negative or fraction exponents. Focus on simplifying the term inside the bracket before expressing the simplified form to the exponent 3 outside the bracket. Watch the previous video tutorials explaining how to apply some of the laws of indices. The link to the video tutorials are provided in the description. You can also click on the link at the top right-hand side of your screen to watch the related videos. Apply the laws of indices interacting similar terms. If a variable with a negative exponent is reciprocated, the math operator will change from positive to negative or vice versa. Watch till the end to see step by step how the fraction form gets simplified to an index form. Notice the final result, C exponent 32 multiplied by D exponent 9 divided by 9. The indices are non-negative and non-fractions. How about you try another example? Simplify and express this fractional form to derive a result that does not have negative or fractional indices. Ideally, we should focus on simplifying the term inside the bracket before expressing the simplified form to the exponent 3 outside the bracket. Apply multiple rules of indices, which have been described in other video tutorials on this channel. See video tutorial links in the description or click on the card at the top right corner of your screen to see the related videos. We can simplify completely the fraction terms by combining algebra and rules of indices. Notice the final result. The indices are non-negative and non-fractions. Consider solving yet another example. Simplify and express this hybrid fractional and surd form to derive a result that does not have negative or fractional indices. To progress through this problem easily, it is necessary to convert all root forms to fraction indices. Then the rules of indices can be easily implemented. For the exponents to interact easily, ensure to express them as equivalent fractions. Equivalent fractions usually have a common denominator. The common denominator is usually the least common multiple of the denominators of all fractions. Consider reciprocating the variable with a negative index. Then 13 divided by 6 should change from negative to positive exponent. We still need to derive a form that does not have fraction index. Split the fraction 13 divided by 6 to derive 13 multiplied by 1 divided by 6. Convert the fraction 1 divided by 6 to a root form, which should be the sixth root. Now you have learned how to manipulate algebraic expressions while employing the laws of indices. Please like, comment and share for more reach. Subscribe for more math tutorials. Stay ahead in algebra, fractions, exponents, surds and other math topics.